We're ready to go. You'll have calculators, because if you're not, come grab one out of the box.
Students, please stop wherever you are and join the Pledge of Allegiance. Attention, salute, pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. Teachers, at this time, please move around your classroom and address any violations of the dress code and mark targets. At this time, we will observe a minute of silence. We reflect, meditate, or pray, or engage in any other silent activity that does not interfere with others. The minute of silence will begin now. Thank you. Students, it is now time for everyone's favorite part of the day. That morning announcements with Brian Escalante. The North Dance Company auditions are coming up May 3rd to 6th.
Is Michaela in that too?
Today.
Is Michaela tennis
Audition
too?
packets are digital this week. The Google project code is SHE3KLP. And flyers have been posted around the school with audition information. Are you ready to step into next school year? Step will be having a pre-tryout clinic Wednesday, May 12th through Friday, May 14th. Trials will be held on May 19th. All sessions will be held in the lower conference from 3:30 to 4:45. Please stop by G112 to get an application from Ms. Chapman. Application packets are due by Monday, May 10th. PC and Go Guard auditions are Friday, April 30th from 3:30 to 6:30, which is today. Would you like a personalized parking spot for next school year? They're now for sale with the forms in the back of the upper conference with prices starting at $50. Forms are due May 14th. Prom tickets are on sale before and after school at A122 or A119B at both lunches in upper conference. Prom is neighbors at the Manor at Coffee Creek. Tickets are $40 and you must have your classes paid before you can purchase a ticket. Get your students rather than later. Today will be the last chance to buy a ticket. Go green with the PCM library. Stop by your PCM library now through the end of April to check out our book display and new recycling station. Plus, enter our drawing for a gardening thing giveaway, which includes a $10 TLC gift card, books, tools, seeds, and more. Students, specifically seniors, please return any overdue books to your PCM library. Read them now through April 30th, which is today, and we'll waive those fines. No questions asked. We don't care if you have the books since freshman year. We'd rather have them back in circulation for future student use. Please contact your friendly neighborhood library staff with any questions or concerns. Enrollment senior dates in May. May 19th is Senior Bunch. Tickets are $20 and will be sold next week, May 3rd through 7th. It will be held at Oklahoma Christian University in Denton. May 20th is the baccalaureate at 7 p.m. at PCM. May 21st will be graduation practice at 1 p.m. at the football stadium. May 22nd will be graduation at the stadium. Seniors must arrive at 8:30 and it will begin at 10 a.m. Creative Writing Club meets Thursday from 3:15 to 4:15, A119A, Ms. Roman. Everyone is welcome to come socialize and write. And remember, pick it up and it's a great day. It's great day. We'll be there.
Okay, Grady and Austin, can you hear me?
Yes.
Yeah.
Okay. Your iPads have, or your phone, wherever you want to look it up on, but the assignment 6.7 I typed up in the questions are on your iPad. So Alicia, did you and Chadwell find it?
For the Google Classroom, yeah.
Okay, so you go to Google Classroom and it should be the first one or last one, whichever one. So can everybody check and see if you can see 6.7 homework? Because it's all application problems, so we're going to spend today going through those application problems. So did you guys find it?
Yeah, I got it.
So you found it, Alicia, or did you say something else? Okay. So was that Austin or Grady that said they found it?
It was Grady.
Okay, Austin, did you find it yet?
Yes, I did.
Okay, so we're waiting. Alicia, do you want a hard copy or you find it? Okay, there's also should be a formula sheet somewhere there. It may be the first page. Did you guys see the formula sheet too?
It's on the first page.
So I gave you guys a copy of it in hard copy, but so Austin and Grady, it's on the first page. Did you see the formula sheet?
Yes, I did.
Okay, so the two main ones that we're going to be looking at are the exponential growth and the radioactive decay. So we're going to kind of put those together. Those are the ones we're going to look at first. There's also, and I can't remember if I put it on the one online or not, there's also an additional formula for radioactive decay that we're going to put on that says M of T equals M sub 0 2 to the negative T over H. So is that on the one on the online?
Yeah.
So it's written on there? Okay. All right, so we're going to go ahead and get started with the first one. Does anybody know anything about Michaela? All right, so this assignment 6.5 to 6.7, it says 6.5 to 6.7 is due on May the 2nd. So that should be Sunday, right? So you have those three assignments that are due on Sunday. So 6.7, the first one says, you go to the doctor and he gives you 15 milligrams of radioactive dye. After 24 minutes, 4.25 milligrams of dye remain in your system. To leave the doctor's office, you must pass through a radiation detector without sounding the alarm. If the detector will sound the alarm if more than 2 milligrams are in your system. How long will your visit to doctor take, assuming you're given the dye as soon as you arrive? Okay, so the first thing we have to do is we have to decide if we're using growth or radioactive decay. Well, obviously this one says radioactive, so we're using that one. So the formula we're going to use for number one is M equals M sub 0 e to the negative RT. Now, M sub 0, anything that has a subscript on it is going to be an initial amount, okay? The M is the resulting amount. So M sub 0 is what you start with, M is what you end with, okay? So it says, after 24 minutes, 4.2 milligrams of dye remain in your system. So the 4.25 is going to be what remains in your system. So that's going to be the thing that's in your system, okay? then it says 15 milligrams was given to you. So 15 was what your initial amount was. And then it says that you had 24 minutes. So negative R times 24. Now, last time we learned how to solve an exponential equation. Now, why is this an exponential equation? What makes something an exponential equation? Well, not necessarily the E, because you can have an exponential equation without an E.
The variable in the square.
There you go. Did you hear what he said? The variable in the power. So the first thing we're going to do is we're going to isolate. Okay, so we talked about isolating last time, meaning that we're going to get this by itself. So we're going to divide by 15 on both sides. So the 15s are going to cancel out. Now, we can go ahead and leave it like this, or we can go ahead and change it by dividing. But if you change it by dividing, make sure you remember that you want to take it out at least 6 places so you don't have rounding error. So let's go ahead and just take the natural log on both sides. Now, last time we learned that the natural log of E, when we have E in there, we use natural log. When we have the no E, then we use common log. So on this one, we have an E, so we're going to use natural log. So we're going to say natural log of 4.25 over 15 equals the natural log of E to the negative 24R. Now, we learned those 3 laws of logarithms last time. So the 3 laws of logarithms, what happens to this power now? Where can it go? Remember last time's homework? What did we do with the power when we took the natural log? It's the 3rd law of logs. You have your notes? What's the 3rd law of logarithms?
Goes to the front.
So the exponent goes to the front. So we're going to have natural log of 4.25 over 15 equals negative 24R natural log of E. Now, again, what did we talk about last time? We said natural log of E is always going to be what? 1. So we're going to make this be a 1. Now we're solving for R. So what do we get for R? We're going to divide by a negative 24 on both sides. So that cancels out. Now, when we get R, I want you to take it to 6 decimal places. So when you do that, you're going to make sure that you have a calculator, obviously, that does natural log. So does everybody have a calculator to use this? Michaela, Austin, Grady, do you guys have a calculator?
Yes.
Okay, so does everybody see where natural log is?
Yeah.
So when you do this, make sure you put parentheses around the negative 24 and make sure that you put parentheses around the 4.25 over 15. So see if you can put that in your calculator. Anybody have an answer?
I got 0.052547.
You agree with him? That's a 7. So 1, 2, 3, 4, 5, 6. Does everybody understand how to get that number?
Yes.
Okay, so Austin, Grady, Michaela said she got it. So did you guys get it?
Yeah.
Austin? Austin, are you there? Austin,
Yes.
okay, did you get this number?
Yeah.
Okay, so everybody's okay with the R. Now, that's the rate that it's going to be going out of your system. So now we have to take into consideration that to get out of the place, you have to decide whether you've got 2 milligrams of dye or not. Okay, so you started with what again? How much did you start with?
15.
15. So we've got our m equals m sub 0 e to the negative RT. So we still have 15 is what we started with, but to get out of there, you have to have 2, right, or less. And your R now is the 0.052547, but it's negative, and T. So once again, you've got an exponential equation you have to solve. So what are we going to do first? Same things last time. What did we do first?
Exponent in front.
Okay, before we have to do what with that 15?
Divide by 15.
Divide by 15, right? Just like we did up above, we divided by 15 first. That's called isolating. Now to get this down on the line, we have to take the natural log. So this comes out front, 0.052547t, natural log of e. So what's the natural log of e? What do we say this was always?
1.
1. So now how do we solve for t? We're trying to get t by itself. So what do we do now?
Divide by 0.05.
0.052547 on both sides. So the question says, how long will the visit take, assuming you're given the die as soon as you arrive? So what do you get for this final answer? T is going to be approximately what?
Negative 38. I got negative 38.
This should have been a negative when we brought it out front.
Alright, I was gonna ask about that.
Yeah, it should have been a negative. So make that a negative, bring it out. So then it'll come to be positive, right?
Yeah.
So how much you say third nearest? It says to the nearest minute. So 38 minutes.
Yeah.
So everybody able to get the 38?
Yes.
Yes.
Grady?
Yeah.
Okay, so everybody's okay on number 1? All right, number 2. The half-life of radium-226 is 1590 years. If a sample contains 500 milligrams, how many milligrams will remain after 1,000 years? Okay, so the first thing we have to do is consider what our R is. We have a half-life of 1590. Okay, so if you look on the radioactive decay problem or formula, there should be a second formula on there too. You see a second formula on there? We've got m equals m sub 0 e to the negative RT. But do you see the other formula there? Okay, you guys got the formula sheet in front of you?
Yeah.
Where it says where, what?
ln2 over h.
So ln2 over h is what? R? So everybody see that second formula? So before we can put it into this formula, we have to put it into this formula to find the R, right? So what does it say the half-life is?
Do we put the 15?
The 1590, so we get R equals natural log of 2 divided by 1590. Does everybody agree with that? So what do we get for R? Again, we want to take R to 6 places. Now, R may come out with a weird thing on your calculator. Do you see at the end of R is like a negative e to the R or e to the R, negative R, something like that? Okay, that's scientific notation. So we're going to move the decimal 4 places to the left before we write it down. See, everybody get that on your calculator? Do you see like a -4 at the end? Michaela, Grady, Austin, do you guys see that at the end?
Yeah, I see it.
Yeah.
Just means moving your decimal 4 places to the left. So now what's R gonna be? Negative? Or not negative, is it positive here? Yeah, positive here.
Would it be like 0.004 or like 0.4? I don't know how many zeros.
So we said 4 places we're gonna go over. So 1, 2, 3, 4, right? So then that would be 3, 6.
Yeah.
So everybody agree with that for the R?
Mhm.
Does everybody know why we had to move the decimal to the left? Your calculator was putting it into scientific notation. All right, so the rest says, if a sample contains 500 milligrams, how many milligrams will remain after 1,000 years? Okay, so what is the 500 going to go in for?
The M
The M sub which one? M or M sub 0?
and I don't know.
Okay, it says if a sample contains 500, so that's the
Oh.
starting amount, right?
Oh, 0.
So M sub 0. So we're going to have M equals 500 e to the negative r, but there's our r over here, right? 0.0000436. And then the t, it says after 1,000 years, right? So we're going to put 1,000 in for t. So you agree with the plugging in part?
Mhm.
So on this one, all you're going to be doing is multiplying it out, right? So you just put this in your calculator. Now, when you put this in your calculator, I would put parentheses around my exponent to make sure the calculator knows that whole thing is your exponent. So anybody get an answer for M? It says take it to the nearest 2 decimal places.
Um, 3.323.31.
3-1.
Yeah.
Does everybody else get 3-1? Alicia, is that okay with you? 3-1? All right, so what's my units on my answer? What did I find by doing that?
Milligrams.
Milligrams. So that's the mass that's left after 1,000 years. So we're okay with number 2? Okay, I'm gonna need to get some, yahoo, done, good job. All right, good job. Number 3. The half-life of polonium 100. Now, one of the things about these two is don't worry about the 226 and the 100 because that's just the name of whatever it is, right? So that's like their last name. So the half-life of this thing is 4 days. After 24 days, a sample of this has been reduced to a mass of 4. What was the initial mass? What is the mass in 6 weeks? And enter the exact value or round to 4 decimal places. Okay. So the first thing it asks us for, the half-life is 4 days. So what do we do with that 4 days? What do we find with that?
T. Is it 4 and T?
What did we do in the previous one when we had half-life?
Ow. LN 2 over H.
Okay, so we're gonna have R equals ln 2 over what's our H? What did we just say it was?
4.
4 days. Everybody agree with that? So Michaela, Austin, Grady, do you guys agree with that?
Yes.
Okay, so you put that in
Yeah.
the calculator. What are we gonna get then?
0. What do we do? 6 or 4 decimals?
6.
0.1732877.
Okay, so you agree with him? Everybody get that number for the R first?
Yes.
All right, so then it says, after 24 days, the sample has been reduced to a mass of 4. Okay, so we've got our M equals M sub 0 e to the negative RT. So it says after 24 days, a sample has been reduced to 4. So where does the 4 go? Okay, now it's reduced to that, it's become that. So if it's not starting at that, it's reducing to that. So where's the 4 go? So you've got, this is your ending mass, this is your beginning mass, right? So it's going to be this one right here for 4, right?
Yeah.
And then it says after 24 days, it's going down to that. So what's the 24 going to go in for? The T. So we've got M sub 0 e to the negative, our R is 0.173287. And you said 24 is going to go in for the T. So now what are we solving for? M sub 0, right? So use your calculators and see what you get. Oh, let me tell you how you do that though. We're looking for M sub 0. So if this is multiplied times this, how am I going to get it to be calculator ready? So I'm going to divide all this stuff on the other side. So I've got e to the negative 0.173287 times 24. And that's on both sides, right? So that's going to cancel with that, and you're left with this thing. So make sure you put parentheses around your exponent. All right, I'm going to ask one of you guys that's on the computer, I'm going to ask you guys to tell me an answer. So I need everybody to make sure you have an answer. 4 divide this long thing, right? And that's going to give me M sub 0. And it says to take, let me see what it says to take it to. It doesn't say, I guess, to 4 decimal places. Let's go. All right, so Austin, what did you get?
Second to last number, an 8 after the 2.
Do what?
Yeah, I think it is.
You got 4 divide e to this long thing.
My calculator said syntax error.
Did we get you a different calculator, or are you still using that other one?
I'm using the one that you gave me, but it still said
Okay,
error.
so do 4 divide second function ln will bring the e to the x button up. Do you see e to the x now?
Yep.
And then put parentheses.
I did.
What?
I did.
Then negative 0.173287 times 24 parentheses equals. So what do you get?
0.06 or negative 0.06.
Did you do 4
Two.
divide to begin with?
Yeah.
Okay, you should get something like 200 something.
Oh. Yeah, I
Okay.
did 4. The 4 divided by that big number.
No, but did you e to that big number?
Yes.
Ask if he times the parentheses. Ask if he times this one number and then the 24.
Did you times the 24 inside the parentheses?
Yeah.
Okay, let's try it finger for finger. Okay, 4. Okay,
4.
all that other stuff out.
4
Divide.
divide
Second function.
ln. Yeah.
ln. So now it should say e to the x on the bottom, right?
Yeah.
Okay, so now you're going to be putting parentheses. negative 0.173287 times 24 parentheses equals.
I got 256.00125.
Yay! Good job, Austin. 56.001 milligrams. All right, so good job. So now you see what you did wrong?
Yes.
Okay. So this was the first answer though. The first one says, what was the initial mass of the sample? So M sub 0 we said was always going to be the initial mass, right? The second one says, what is the mass 6 weeks after the start? Okay. So what is the mass 6 weeks after they start? You're going to have M equals M sub 0 e to the RT again, negative RT. Now we have to ask ourselves, how do we fill this in? Okay, so what is the mass 6 weeks after they start? But up here, we did days, right? So if we do days up here, we've also got to do days down here. So when I plug this in, it's going to be M equals, what is M sub 0?
256.001.
Okay, so we're going to put in 256.001. That's my M sub 0. E to the negative R, so we found R to be that negative 0.173287, right? Now, what are we going to put in for our time? If it says 6 weeks, but up here it was days, we need to convert this one to days then, right? So what are we going to put in for the time? If we got 6 weeks, that's how many days?
42.
42, right? 6 times 7 days a week. So now it's just straight putting it into your calculator. So you've got 256.001 times natural log of, second function natural log of x, and then this is going to come up. But again, I would put this in parentheses for your exponent. And it says round it to 4 decimal places. Okay, Alicia, did you get an answer? 256.001 times E, that's going to give you the natural log of second function natural log, right? Parentheses, these two multiply. So if we're going 4 decimal places, it's 6, what would this be? Good job, 8. 0.1768 milligrams. So did everybody get both of them? Okay, like I said, putting it in the calculator is going to be the biggest thing if you get it right by setting it up, but then you can't put it in the calculator, so you need to make sure. All right, the next one is number 4, right? Okay, number 4 says, at the beginning of an experiment, the scientist has 396 grams of radioactive goop. Michaela, did you find the hard copy of this? I can't remember if you came in and I told you how to find where the questions were.
No, I don't know where it is.
Okay, go to your Google Classroom. You can do it on your phone or wherever you can do it. And it should be which assignment is it? The first assignment?
Sorry, it's loading.
Okay.
Okay, I got it.
So you now see where it is?
Yeah.
Okay. All right. So everybody on question 4 now? Okay, so question 4 says, at the beginning of an experiment, a scientist has 396 grams of radioactive goo. After 150 minutes, her sample was decayed to 6.1875 grams. What is the half-life of goo in minutes? Find the formula for G of T with the amount of goo remaining after time T. And then how many grams of goo remain after 20 minutes? And round your answers to 2 decimal places. All right, so let's go back to the beginning. At the beginning of an experiment, a scientist has 396 grams of goo. Okay, so after 150 minutes, the gram decayed to 6.1875. So we've got M equals M sub 0 e to the negative RT. Now, what do we have to do with this? What do we know? It says the beginning of her experiment was 396 grams. So where's the 396 grams going to go? Says at the beginning of her experiment, she had 396
Versus 0.
M sub 0. So the 396 goes in for M sub 0. And then it says after 150 minutes, her sample has decayed to 6.1875. So where's the 6.1875 going to go? The M. So we've got 6.1875. And then we've got up here, it says after 150 minutes that happened. Okay, so what's the 150 minutes going to go in for? The T. So everybody agree with that substitution first? So what are we solving for?
Or
R, right? So what do we have to do first in this problem? Same as those other two we did earlier. What do we do first?
put the R. Or divide by 396.
Divide by 396. We're going to isolate first. Now you can leave this as that fraction because later on we're going to put it in our calculators. So I get now I've got an E. So to get the R down on the line, what do I do on both sides? Natural log. So natural log of 6.1875 over 396. Now, what do we do natural log? This causes this is to what? Come out front. So negative 150R natural log of E. So you agree with that? When I took the natural log on this side, it caused this to come out front. That's the third law of logs. So what is natural log of E? 1. So every time you see natural log of E, you can cross it out and put a 1. So Austin, I'm solving for R. So what am I going to do on both sides?
Divide by negative 150.
Divide by negative 150. Good job. So that cancels out. So now putting this in parentheses. So you're going to take natural log parentheses, this divided parentheses, divide parentheses negative 150. Now we said R, we're always going to take it to 6 decimal places. So Grady, you got an answer for 6 decimal places?
My calculator's saying sign whatever it is error.
Okay, so are you ready to start again so I can tell you how to do it in your calculator?
Yeah, go ahead.
Okay, natural log of n is going to be down on the left-hand side of your calculator, right? You see natural log?
Yeah.
Okay, so you're going to push that first and in parentheses, 6.1875 divide 396 parentheses. So you got that part?
Yeah.
Then divide parentheses, negative 150 parentheses. So you should get a really long number.
It just says error again.
Okay, tell me what you put in.
Well, I just cleared it. It was what you told me to put in. I just typed it in as you said what to put in.
Okay, let's try another way. Natural log. Is this natural log?
Yeah.
Does it give you the first parentheses?
Yeah, it does.
Okay, so 6.1875
Yeah,
divide 396 parentheses.
Yeah.
And then push enter. And
Yeah.
then divide parentheses 150 parentheses.
say it again.
After you push enter, do divide parentheses
Yeah.
negative 150 parentheses.
And then press enter.
Yes.
It says error again. I'm just gonna have to come in and get one of your calculators because I got a different calculator and this one isn't working either.
Okay. So you'll come by today because you really have to
Yeah.
have doing homework.
Yeah, I will.
All right. So we've got 0 point. Anybody else get a number?
Miss Adams, how many decimal places is it?
On R, we're going to always go 6.
Okay. Do you want me to say the answer? Because I think I got it.
Okay.
0.027726.
Very good.
That's 6.
0.027726. So does everybody agree that's R?
Mhm.
All right. So the second thing it asks for is, what is the half-life of the goo in minutes? All right. So if we're looking for half-life, what formula do we need to go to?
ln2 over h.
So we got R equals ln2 over h. Now, if I want to switch this around a little bit and do cross product on the formula first, I can get RH equals ln2. You agree with that?
Mhm.
But I want to be able to plug in R to get H, so I'm going to divide by R on both sides. So this is going to tell me H equals natural log of 2 over R. So that's the same kind of formula as we started out with. It's just solving it for H instead because we're looking for half-life, right? So you agree with how to switch the formula? So we're just going to plug in natural log of 2 divided by Michaela's 0.027726. So the half-life, it says, is going to be how much?
24, and then what do we round it to like this?
I'm looking to see here. It just says half-life in minutes. So I'd say to the nearest minute. So what did you get to the nearest minute?
25.
So you guys agree with him, 25? Okay, so we have R from up here. And we have 25 minutes for the half-life. All right, so now we're going to look into the next part it asks us for. It says, find a formula for G of T the amount of goo remaining after T time. Okay, so that's the one that we had before. I told you there was an extra formula that you had to add down. Okay, so the formula we're going to look at, I guess I still need that though. Hang on a second. All right, so you guys have all this written down so we can go back and reference it, right? Okay. So it says, for a radioactive substance with initial amount as m sub 0 and half-life h, the amount remaining after time t is modeled by m equals m sub 0 2 to the negative t over h. All right, so this one asks us to find a formula for the amount of goo remaining at time t. Okay, so we just found the half-life, right? What did you find the half-life to be? 25 minutes. We also know what our initial amount was at the very beginning. So what was our initial amount at the very beginning? 396. So we're going to have m equals 396 times 2 to the negative t over, what was our half-life? 25?
Yep.
Okay, so this is going to be my formula. Says, find the formula for the amount remaining at time t. So then the next thing says, how many grams will remain after 20 minutes? So what are we gonna do with that 20 minutes?
Put it in for T.
Put it in for t, good job. So m equals 396 times 2 to the negative 20 over 25. Okay, so now you have to be careful on this one because you got to remember this 2 is the only thing taken to the power. So sometimes what I do when I put it in my calculator is I do this first and then I multiply by 396. You may not have to, your calculator may automatically do it for you. But again, put parentheses around your exponent. So 2 to the power is going to be that caret top, right? Does everybody see where the caret top is? I think it's on the right-hand side of your calculator. So 2 to the caret top, so that gives you a parentheses. Negative 20 divide 25, parentheses, enter. Get that answer and then multiply it by the 396. So we got m is approximately, it says 2 decimal places.
Is it 227.44?
227.44, good job. So we're okay on that one for number 4? Yes or no?
Yep.
All right, any questions before we go to number 5? Okay, so number 5 says, a wooden artifact from an ancient tomb contains 45% of carbon-14 that is present in living trees. How long ago to the nearest year was the artifact made? The half-life of carbon-14 is 5,730 years. Okay, so the question says first is, how long to the nearest was the artifact made? The half-life of sport is 5730. So what we're going to do is we're going to take, and this is kind of a different way of doing it. So we got m equals m sub 0, 2 to the negative t over h, our formula we created before. Now, when I say it contains 45% of the carbon-14 that is present in a living tree, you're saying that your m sub 0, or excuse me, your ending amount is 45% of what you started with. So if this is 45% of what you started with, what's a way of writing 45% of something? Oh, that doesn't last very long. Okay, how do we find 45% of something?
Do you times it by 0.45?
Good job. So instead of putting m, I'm going to write 0.45 m sub 0. Because this ending amount is 45% of what I started with. So like Michaela said, we multiplied by 0.45 times our original amount. So equals m sub 0. And let's see what else it tells us. It tells us the half-life. So we're going to put what in for half-life? 5730. So first thing, does everybody understand what this means? 45% of the original amount is what's remaining. Okay, you read that? So now, how can I solve to get rid of this m sub 0? I just divide by m sub 0 on both sides, right? That just goes away. So I divide by m sub 0, divide by m sub 0. So those all cancel out and I get 0.45 equals 2 to the negative t over 5730. Now, what am I solving for? T. So it says, how long ago was the artifact made? So in this case, we can do, since we don't have an e, what do we have to do? Use the log on both sides. But the same process is true. Coming inside. Okay, when I take the log on both sides, this power is still coming out front, right? So this becomes log 0.45. And what is this power gonna do? Go to the front, so I get negative t over 5730 times log of 2. Okay, so first, does everybody agree with that? Okay, now, here's where you gotta think of your algebra skills, right? So I can get rid of log 2 by doing what? Divide by log 2. So I'm gonna take log 2 on both sides. So that causes that to cancel out, right? Now, I want to get rid of the negative, and I want to get rid of the 5730. So how do I get rid of the 5730 first? If it's divided, what can I do to get rid of it to bring it over here? Multiply. So I'm going to multiply this times the 5730 to get rid of it. Now, oops, that's supposed to be a 7.
Miss Adams, what are you multiplying like by? That was kind of confusing. Oh, okay. I couldn't.
730 right here, we're multiplying so it'll cancel out, but also at the same time, I want to get rid of that negative, right? So instead of just multiplying by 5730, I can multiply by negative 5730, and that would cause the negative to go away too, right? So I'm going to multiply this thing right here times negative 5730. And you can put it over 1 if you want. So first, does everybody agree with that solving part? Because this is going to cancel out now, and these are going to make that plus, right? So now you should get t to be something when you put in your calculator. So if I was doing it, the first thing I would do is do the parentheses part first. So parentheses log 0.45. Now, notice when you put in log, the calculator automatically puts in the front parentheses there. So you got to put the back parentheses, same thing on the 2. And then enter and then multiply by your negative 5730 in parentheses. So it says to round to, let's see where it says to round to. I guess it doesn't say, so let's go 2 decimal places. Anybody get an answer?
6,600.98. How many decimal places?
2 did I say 2 or 1? Let's go 2.
0.98.
So 660,
0.
there's a 0 here?
Yeah.
Okay, so 6600.98.
98.
Does everybody agree with that number? Okay, Austin and Grady, I want you guys to try this one on your calculator and see if you make it better at this one. So both of you have your calculators there?
Yes.
All right, so we're going to start out with log. So you both got a log on there?
Yes.
Does it show a parentheses?
Yes.
Yeah.
Okay, so log 0.45 parentheses. You got that part on there?
Yes.
Divide log, and again, it's going to put the parentheses in the front. So 2 parentheses equals, or enter. Then you're going to take that number times parentheses negative 5730 parentheses. Enter, and then what do you get?
I got 6,600.977.
Okay, good. So that's the answer then, right? So what did you get, Grady?
I got the same number he did.
Okay, so down both of you got the right answer on that one?
Yeah.
Okay, so this is years. So I need you to keep trying to make sure that you know what you're doing, okay? All right, so next one is number 6. So that's on the next page, right?
Yeah.
Now, remember what I told you from the very beginning, that there was going to be two formulas that they're going to emphasize. So the next formula that they're emphasizing is the population growth. So that formula is the one on your formula sheet, n equals n sub 0 e to the RT. So this is population growth. Now, in science classes, you may have had this in science classes before, where you have bacterial growth and things like that. So this one says, to start out with, the doubling period of a bacterial population is 10 minutes. At time t equals 80, the bacterial population was 50,000. What was the initial population at time t equals 0? Find the size of the bacterial population after 5 hours. Okay, so the first thing we're going to do is we're going to set up the, let me see here. How does it do this? Okay, we're going to set up the formula. So what is going to go in for n? It says at time 80 minutes, the bacterial population was 50,000. So 50,000 is not your initial population, right? No, or yes. Is 50,000 what you start with, or is 50,000 what you get after 80 minutes? After 80 minutes, right? So we're going to put in the 50,000 is going to go into here. Everybody agree with that? Okay, so we've got equals n sub 0 e to the, what's our time? When does it become 50,000?
80 minutes.
80 minutes. So we're going to put 80 R. So you agree with that? Now we're going to come over here to the side for a minute, and we're going to say to ourselves, all right, I have to figure out what the R is, but first I'm going to figure out the doubling period of the population. So what does doubling mean? You start with the amount of population, and what does doubling mean? So this is a side note over here. We're doubling our population. So what does doubling mean to do? If I say to you, you got 50 bucks, I'm going to double that if you do such and such. What am I going to give you? What does doubling mean? Okay, guys, you know what doubling means. I'm going to double your money.
2 times.
2 times it, right?
Yeah.
Okay. So doubling means that you're going to do twice as much, right? So if I'm looking at this formula again, n equals n sub 0 e to the RT, and I tell you that 10 minutes is its doubling time, right? Then that means if I start with this amount, then this over here is going to be twice what I started with. Okay, first, do you agree with that?
Yeah.
This would be twice as much as what I started with, right? 2 times n sub 0. N sub 0 is what I started with. Yes or no?
Yes.
Okay. So now we're solving for what? We're solving for R, right? Because we needed R over here in this formula. So if I'm solving for R, what can I do with the n sub 0s?
Cancel them out.
Cancel them out. So divide by n sub 0. I get 2 equals e to the 10R. Okay, I'm solving for R now. So what can I do on both sides? I'm trying to get R down on the line. So what do I do on both sides? What have we been doing all along on these?
Log.
Log or natural log?
Oh, natural log.
So natural log. Now what?
Divide by 10 after you do the LNEs 1.
So that's 1. So I divide by 10. Okay, now I guess in realistically, I didn't even have to go through this process, right? I could have done that to find that anyway. Okay, so we're actually going to plug in for our, that this is going to be what our R is right here, but we're going to go ahead and get a decimal approximation. So someone take it on your calculator, and what do you get as a decimal approximation?
0.069315.
Did anybody else agree with him? So we know we have agreed with it. Did you try it, Alicia? Natural log of 2 divided by 10. Okay, so everybody agrees with this number for R? Okay, so we're gonna plug it back in up here. So we get 50,000 equals n sub 0 e to the 80 times that big long number, right? $9,315. Sorry, I kind of squished it up in there. All right, so let's figure out what we're trying to find again. We're still trying to find the initial population. So what am I solving for now?
Bacteria population after 5 hours.
Well, but I still have to find the initial population right here.
T.
So what do I have to do to get n sub 0? This is multiplied times this. So what do I have to do to get it?
Divide by all that.
Divide by that big long thing again, right? So 80 times the 0.069315 on both sides. Like that other one that we did just a few minutes ago, right? So everybody try it and see if they can get a number. So we agree with each other. So this is going to cancel out on this side, right?
Yep.
And hopefully you're going to get something like 100 something.
I did not. Oh, wait, I did this wrong one. Yeah, I didn't get 100 something, but I got like 19.
19.
I got 19.5.
Did you put in 5,000 or 50,000?
5,000. Oh, yeah.
Okay.
I put in 5,000.
So did we get an answer from anybody besides? I got 195. Okay, make sure you put parentheses around the power.
Yeah, I got
You did? Okay,
195.308.
195.3.
How many?
Let's just do 2 decimal places.
Then 3-1.
3-1. Okay, Michaela, take, not Michaela, Alicia, take 50,000, divide, and then do parentheses, because I want that in parentheses first, right? And then natural log of x, right? That brings your e up. Parentheses, 80 times your 0.01. What is it? 01's what? That's not 1, it's 0.69315. Is that right? What'd you get again, Chadwell? 0.068315? Yeah. And then parentheses equals. Did you get all these numbers in the right order? Because they're kind of small written there. 80 times 0.068315. And you got 130 some? 1.32. Okay, what about you guys that are on the computer? Michaela, did you get a 195?
My computer like froze for like 5 minutes, so I'm trying to like catch up. So sorry.
Okay, Austin, Grady, did either one of you get 195.31?
Yes.
That was Austin. Grady, what did you get?
Sorry, one second. I couldn't figure out how to unmute. Same as that one.
Okay, so let's try one more time. Okay, so you get everything cleared out, right? So 50,000, make sure you're doing 50,000, right? Divide, parentheses. And then your natural log, second function natural log, right? That gives you your power, right? So parentheses, 80 times 0.069315, parentheses, enter. It didn't come out? Okay, maybe we can, at the end, we can go over it together. All right, so we still have part of this problem we haven't answered. This is my what? What does it stand for?
The
what?
the population.
The initial population, right? So in this case right here, when we started out with this initial population, we were talking about 80 minutes, right? This 80 was minutes. So the second question it asked you for is, find the size of the bacterial population after 5 hours, okay? So we're looking for the population after 5 hours. So we're gonna plug in stuff that we know into that formula. So we're gonna get n equals n sub 0 e to the RT, right? So what are we gonna plug in? We're gonna find n. N sub 0 is your what?
195.31.
0.31. Your R is what?
0.069315.
0.69315. And then our T,
So you're going to 300.
yes. Okay, did you hear what Chadwell said? The 300 now, because it says, what is the size of the population after 5 hours? Well, 5 hours, we got it to be, have to be in minutes. So how many minutes in an hour? We've got 60 minutes in an hour, right? So 60 times 5 means that our time is going to be 300. So instead of T, we're going to have a 300 put into T. Now, this should be just straight across putting it in your calculator. There shouldn't be any logs on either side or anything like that. So we're just going to get 195.31 times e to the x parentheses, that stuff put in. So let's see what you get.
Really long number.
A very big number. Okay, did you guys get a really big number? 2.097 times 10 to the 11th.
Yep.
You see that e to the 11 at the end? Now it probably comes out with more decimals here. It was probably like 152 or something like that.
Yeah.
And this would be the population. Bacteria grows pretty fast, doesn't it? In 5 hours, it went from that to this. That's kind of scary. So Grady, Austin, and Michaela, did you guys get this when you plug this into your calculator?
Yes, I got it.
Okay, good. Grady,
Yeah.
so that's what you got? Austin?
Yeah, I got that.
All right, so we're okay on this one? All right, that was number 6. So now we're going to number 7. The count in the bacterial culture was 700 after 15 minutes and 1300 after 35 minutes, assuming the growth grows exponentially. What was the initial size of the population? All right, so this one is going to be one like we did a lot in Algebra 2, but we're not used to thinking about it in these terms. So Just a different piece of paper here. So we're still talking about the growth of bacteria. It says exponentially. So we've got n equals n sub 0 e to the RT. So it doesn't say anything about radioactive decay or anything like that. Okay, thank you. All right, so the first one says that the culture was 700 after 15 minutes and 1300 after 35 minutes. So we're going to plug in those two things first into the formula. So what does the 700 and the 1300 go in for? What's going to be two different ones. So what's the 700 going to go in for over here? Is that what it starts at? Is that what it ends at? That's the ending population. So it's going to be 700 equals n sub 0 e to the 15. So 15 is my time. So 15R. You agree with that or not? All right. So Alicia, what's the second one going to be? 1300 after 35 minutes. Same process. What are we going to write? I'm going to set it up just like this, that I'm using 1335. So what's that going to say? So instead of 700, I'm going to write 13. There you go. And instead of 15, I'm going to write 30, is it 35 minutes or something? Didn't say it's 35. It'll go off in a minute. All right, so we have two equations, two unknowns. So do you remember you used to solve them by substitution or elimination? Remember doing that before, substitution or elimination? So that's what we're going to do, is we're going to come up with some way to come up with R by substitution or elimination. Okay, I thought it would go off in a minute. Goodness, they're definitely interesting. All right, so what we're going to do is we're going to solve one of the equations. So in this case right here, we're going to solve this one, and we're going to solve it for n sub 0. Okay, so I'm solving this one for n sub 0. And then I'm going to take that and I'm going to plug it into the other equation. Isn't that what we did with substitution? We solved for one of the variables and plugged into the other equation for that variable. So how would I solve for n sub 0? I would just divide by e to the 15R on both sides. So that gives me n sub 0 equals 700 over e to the 15R. So you agree with that? Now, what do we say we're going to do with this thing? We say we're going to take this and we're going to plug it into the other equation. So if I do that, I get 1300 equals 700 over e to the 15R times e to the 35R. Okay, so does everybody see what I did? I just took this right here, because it's n sub 0, and I plugged it in for n sub 0. So you agree with that or not? Okay, so the next thing we're going to do is simplify this side for a minute. If I've got e to the 35R and I've got e to the 15R, what can I do with those two powers? If they've got the same base, what can we do to the powers?
Just
Add them or subtract them?
subtract.
Because this one's in the bottom and this one's in the top, right? So I'm going to get rid of 15 of them down here. So what does this become if I get rid of 15 of them?
20R.
E to the 20R. Does everybody agree with that? So we've got 1300 equals 700 e to the 20R. But what am I trying to solve for?
R.
R. So what do I have to do with that 700?
L.
Divide, right? Remember, isolate first. Good. So the 700 cancels. The zeros cancel over here. So I get 13 over 7 equals e to the 20R. Now, I'm solving for R. So what do I have to do on both sides to get this R to come out front? What have you been doing all along to get rid of that, to get that R to come out front? ln. And what is the ln e going to do? Cancel out to be 1. So Grady, I'm solving for R, and this is multiplied by 20. So what do I have to do with that 20?
Divide.
Divide by 20. So this cancels out, right? So now you're going to get R on your calculators. You're going to take natural log of 13/7 divided by 20, and we're going to go 6 decimal places.
0.03952.
So 0.030952. Okay, does everybody agree with him on that number?
Yes.
All right, so let's go back and let's see what we were trying to do in the first place. So this is question number 7. So it says, what was the initial size of the culture? So what do we have to do with this R to find the initial size of the culture now?
You put the R into the 701.
Good. Do you hear what he said? Good job, Chadwell. We're going to take this R and just plug it into there, and that would give me my initial size. So I'm going to have n sub 0 equals 700 divided by e to the 15 times this big number, right? Not big number, but a lot of term, decimal places. All right, so see what you get when you divide. Now remember, put this in parentheses. And it's 0.030952.
440.01.
440.01 was the initial size. You agree with him?
Yes.
Yeah.
Yeah.
Yes. Same.
All right, so the next one it asks us for is find the doubling period. Okay, so we're still in the same problem. We've got n equals n sub 0 e to the RT, right? So we're looking for the doubling period. So when I find out what I have to do to find out the doubling period is I have to use that idea of what does it mean to double again. We did that on the last problem. What does it mean to double something?
200.
So this right here is my initial amount. So this would be 2n sub 0 if I'm trying to double it. You agree with that? Doubling the initial amount, you want to double it. And what is my R?
0.030952.
0.030952, right? And there's my T. So I'm saying, it says how long for find the doubling period. So what are we looking for? We're looking for T, right? So how do we get rid of n sub 0? What have we done twice before when we had something like this? How do I get rid of n sub 0?
You just cancel.
Just divide them out. So this would be divided with this. So now I'm going to take the natural log. So natural log of 2 equals 0.030952 T natural log of E, because this whole thing comes out front when you take the natural log, right? So what's natural log of E? 1. Okay, Michaela, how do I solve for T now?
Divide by that big decimal number.
Good job. So our time is going to be approximately in Doesn't say what to round it to. Let's go to the nearest 10th. So natural log of 2 divided by the R gives me T is what?
22.
22.39.
Point, let's go 2 decimal places. So do we agree 22.39?
Yeah.
Now we gotta decide, is that days, minutes, what is that? What did we start with at the very beginning? 15 minutes, 35 minutes, right? So this would be minutes. $22.14. 42. Did anybody else get 22.42? Check and see if you reverse numbers maybe in that, in the R. 0.030952. It's got to be towards the end if you did, because it's that close. Came out the same thing, 14 again? 42. Did anybody else get 42? Well, did you do 952 at the end? Yeah, use this number over here. It's easier to read.
Oh, I thought it was 912.
Yeah, I'm sorry. This is 52.
Okay, then it's
Yeah, it's that, I would say it had to be towards the end to be that close. All right, so the next question asks us, find the population after 115 minutes. So what are we gonna do with that? We're gonna plug in everything but the T, right? To find out for 115 minutes. We're not gonna go through the rest of 7 because I want to get to a few more of the other problems. And then when will the population reach 15,000? So what's the 15,000 gonna go in for? The N or the N sub 0? If it's gonna, when will a population reach that? When will it become that?
0.
Is that the initial one or is that the
Oh,
ending one?
okay.
The ending one, right? So the 15,000 would go in for the N, right?
Mhm.
Okay, so we're okay with number 7?
Yeah.
All right, so let me give you the answers to the number 7, the last two, so you can check your answers. So we just did doubling periods. So the next one is after 115 minutes, it should be 15464.0975 or 76, I guess. That's the after 115 minutes. And then the next one will be when it reaches 15,000 is 114.02 minutes. 114.02. And I think that's all that it asks for on that problem. All right, so now we're gonna look at number 8.
Miss Adams,
Yes,
Austin's texted me to let him back in.
oh, I'm sorry.
He said his computer died.
Oh, no. You okay now, Austin?
My computer. Oh, sorry.
You okay now?
Yes, I am.
It's 552. All right, so we're on number 8. Is that the right one? Okay. All right, so number 8 says the fox population in a certain region has a continuous growth rate of 7% per year. It's estimated the population in the year 2000 was 17,300. Find a function that models the population T years after 20,000. Use an exponential function with base E. Okay, so the first thing we want to look at is it's going to grow, continuous growth rate is 7%. So how do I write 7% to something that I can use in a problem?
0.07.
Okay, so he's moved it 2 places to the left and got 0.07. So we have to change it to decimal before we can put it into the problem, right? So this is going to be our R, and this is problem number 8. And then it says exponentially, so we've got n equals n sub 0 e to the RT, so it's not radioactive decay, right? We're talking about foxes growing. So it says your initial population, what, in the year 2000 was 17,300. So where's the 17,300 going to go? Is this what it's becoming, or is this what it's starting at?
Zero.
So n sub 0, good job. So this is n equals 17,300 e to the 0.07 t, because we're putting in r, right? Now, be careful putting it in, because they may make you write it as n of t. We've just been putting n each time, so we didn't get confused about the t. But this would be like function notation, so they might have you do that. 17,300 e to the 0.07 t. But usually we just write the n so we don't get confused with it being multiplied times t. All right, so this would be the first answer. They ask us for a formula. Find a function that models, and they call it P of t, I guess. So the B answer says, use the function that you have to estimate the fox population in the year 2008. All right, so what does 2008 mean to us? Well, we started in 2000, right? So how long have we been going to be in 2008 now? Okay, guys, that's silly. You started in 2000 and now you're 2008. How many years have we gone by? 8 years, right? So what are we gonna do with the 8 years?
Put in T.
Just plug it in for t, right? So you've got 17,300, 0.07 times 8. So see what you get when you plug it in. Let's go to the nearest fox. 30,000 something.
I got 30,286 or 87 again.
17300, that 3 is kind of creepy looking. E to the 0.07 times 8. Put this in parentheses. Do you guys agree on the computer? Austin, Grady, Michaela?
Yes.
And we took the decimals out, right?
Do what?
We took the decimals out, right?
Yeah, I think so.
Took the
Yeah.
desk, that way you mean. Oh, yeah, because it's to the nearest fox.
Okay, thanks.
Still not coming in?
Not yet.
Okay. All right, so we're okay with number 8? All right, number 9 says a flawed reactor design played a part in the nuclear meltdown. Apparently, approximately 14,252 units of radioactivity were initially released into the environment. Only areas with less than 800 are considered safe. The function equals now. I think I wrote above what the function was because it didn't come out printed right. So it gets f of x equals 14,252, 0.5 to the x over 32. Okay, so that should be the correct formula, right? Describes the amount of radioactive element remaining in the area X years after 1986. So X is years after 1986. Says find f of 40 to determine the amount of whatever that is in 2026. Round your answers to the nearest tenth as needed. Okay, so where did they get the 40 from? Why did they decide they wanted to do by 40? Where's the 40 come from? When does it say you're starting? You guys got the paper, what does it say? When does it say you're starting? I don't think 20, I think right, the line before that, what does it say?
Oh. 1986.
So you're starting in 1986, right? And you want to know what it is in 2026. So if I subtract those two, what am I going to get?
Oh, 40.
40, right? 40 years. So that's why we're plugging in 40, because they want to know what it's going to be in 2026. Does everybody agree with why that's 40? So we're going to put F of 40, 14 to 52, 0.5 to the 40 over 32. Now, this is an exponent, right? So you just got to remember that. And if you want to change this exponent to a decimal first, this one's going to come out even. I wouldn't change it to a decimal unless it comes out even, but if you take 40 divided by 32, you should get something like 1 point something. So do you get 1.25?
Yeah.
Okay, so I've got 14 to 52 times 0.5 to the 1.25. So what do you get for F of 40?
59.92.22 or 23.
Do you agree with him? All right,
Yes.
so what does that stand for? What is that 40? What do we say 40 stood for?
No. Equals.
Yeah, I'm not sure what that is, but you're right. Amount of those things in the year
2026.
2026. Now, it does say round to the nearest tenth, so that would drop off the 3 then, right?
Yeah.
Okay, so then it says, determine if this area is safe for human habitation in the year 2026. So what does that mean? How do we know whether it is or not? It says up in the initial part, it says only areas with less than 800 are considered safe. So do we have 100, 800? We have 5,992, right? So if the only places that are considered less than 800, and we've got this many, is it safe or not safe? Is 5,992 less than 800?
No.
No, it's a lot bigger, right? So it says only areas with less than 800 are considered safe. So is ours considered safe?
No.
No, so this would be not safe. Do you understand why it's not safe?
Yes.
Okay. All right, next page, number 10. We're getting there almost. Last page, right? Or maybe next to the last page. Goodness. All right, so on that one, it looks like it's multiple choice because they said no, because, and this and that. All right, so number 10 is the next one. So we're okay with 9?
Yes.
So are you guys online doing okay?
Yes.
Yes.
Okay, so number 10. The number of bacteria in a culture is given by the function N of T equals 900 e to the 0.3 T, where T is measured in hours. Okay, what is the relative growth rate of this population? What is the initial population? And how many bacteria will culture contain at time t equals 5? Okay, now guys, this one is very straightforward, right? You're going to look at the problem and you're going to tell me some answers. So the first one says, what is the relative growth rate? So if this is n equals n sub 0 e to the RT, what is your growth rate? You don't have to do anything on your calculator, you just look at the problem and tell me. What is your growth rate going to be? Which ones are going to be your R?
0.3.
So if R
Point
is
three.
0.3, right? How do I put this in a percent? 2 places to the right,
30.
so it's going to be 30% is my growth rate. See why it's 30%? Okay, the second question says, what is the initial population of the culture at t equals 0? Okay, guys, we've been talking about this the whole time. What is the initial population? So what does it look like for the initial population? Look at the equation and tell me the initial population. 900, right? We said n sub 0 stands for initial, right? The starting population, n is the ending population. So this is 900. So what would the C answer be? It says, how many bacteria will be in after time equals 5? So what are we going to do with the T? Plug in a 5, right? So 900 e to the 0.3 times 5. So that's just really easy plugging in. So what do you get to the nearest back? It says to the nearest whole number. So Grady, you got an answer for me? 900 times e to the parentheses around this?
Say it again.
You're going to just plug this in your calculator, 900 times natural log of e to get natural log to get this, and then you're going to put parentheses around your exponent. Tell me what you get. It says to the nearest whole number too. Did you get a number?
It said error again.
Okay, let's try it one more time. 900. Got 900 in? Grady?
Yeah, I did.
Okay, so 900 times, and you do natural log, right?
Yeah.
And that, do you see e to the x now up there?
Yeah.
So on x, I want you to put in parentheses, 0.3 times 5 parentheses. Don't do that other set of parentheses. Parentheses, 0.3 times 5 parentheses equal.
It still says error.
What kind of calculator, what is it, does it have a name on the outside of the calculator?
No, ma'am.
You just know blank, this is blanco calculator?
Yeah. Yeah.
All right, so you're coming by. Okay, so Alicia, what'd you get?
40333.52.
Okay, so it's the nearest whole number, so 3 what?
3.
So what's the, is it 3 point or something after this?
4033.5.
Okay, so 5 is gonna round the 3 to a 4. You agree with that? Okay, so my answer is 4,034 population. So we're okay with number 10? Okay, next one, number 11, talking about radioactive decay again. So that's jumping us to what kind of formula? Actually, I guess it gives you the formula in number 11. So we'll just use whatever they wrote down. Okay, so 11 says certain radioactive material decays in such a way, mass remaining after T years, so T is in years, is given by M of T, which is just the same as M, right? 225 e to the negative 0.01 T. Okay, so again, try to let the easy ones be easy. Number 11 says, find the mass at time 0. So find the mass at time 0 means what? You haven't gone any time, right? So that's the same thing as saying the initial amount.
Yeah,
So what's my initial amount?
0.
Look at my equation. What's my
225.
initial amount?
Is it 225?
225. So the answer to my first question is find the mass at time t equals 0. That's my initial time, right? So it's going to be 225 grams. So that's my first answer. Okay, the second answer says, sorry, I'm on the wrong question. How much of the mass remains after 15 years? So what are we going to do with the 15?
Just put it in for T.
Just put it in for t. So your second one's going to be mass equals 225 e to the negative 0.01 times 15. So you just put it in your calculator, multiplying straight across, right? No solving with logs or anything like that. So what'd you get?
193.66.
Okay, did it say what to round to? Let me see. Round to 1 decimal place.
193.7.
7 grams. Okay, so that's all we got to do. All right, number 12, I said it looks like number 6, so we're just going to leave you to go back to number 6 on number 12. But I will tell you the answers. So you ready for the answers?
Yeah.
12 is 3750 at t equals 0, 3750. And then at 5 hours, it's a really long number. 122880000. 122880000. So we're okay with that one? All right, so we're looking at 13. Okay, number 13 says the function f of t, and it's written incorrectly in the typing, so I'm going to write it here for you. And I may have written it at the top already. Okay, so it should look like that. All right, so it says the function f of t describes the number of people who have become ill with Ebola t weeks, so t weeks, after the initial breakout in a particular community. How many people became ill when the epidemic began? So how many people became ill when it very first started? So when it very first started, how much time had gone by? 0. So 0 time has gone by. So all we're going to do is plug in 0 for t. Now, you can do part of this in your head. You got 575 divided by 1 plus 4,000 e to the negative 0 now, right? Because we said that when you start, it's going to be t equals 0 because no time has gone by. But what do we know about e to the 0? Anything to the 0 power is what?
1.
1. So that's going to become 1. So now I've got this 575,000 divided by 4,000n, because 1 times 4,000 would be 4,000. So divided by 4,001. And then that would give me my answer for this one. So they're asking for how many people had it at the beginning. So what is 575,000 divided by 4,001?
143.7.
Okay, so we're going to talk about people. So 144, is that right?
Yeah.
Okay, so 144 people is the first answer. The second answer asks us to find out. Okay, that was the first answer. The second answer must be on the next page. How many people were infested 6 weeks after the breakout? Okay, so how many people were infected after 6 weeks? So what are we going to do with the 6 weeks?
You're going to put the 6 to the east.
6 is gonna go in for T, right? Okay, so the second answer, so this is the A answer. The B answer is gonna be 57,500,000. 1 plus 4,000 e to the negative, what was it, 6? So again, put parentheses around your base and then just plug it in. So we started with 144 people. Now after six what? Hours, weeks, what is it? After 6 weeks, then how many people are dead or infected?
57,923.
That's not what I got.
Is it 52,679?
Would it be 79 or would it be 80?
80.
So 52,680,
Yeah.
okay? Is that what you got? Okay. And this is what, people again? So it started with 144 people, and now it's 52,680, right? And this kind of goes along with what we've been going through with the pandemic, right? You can see how fast it grows when you have something like this. Now, the last question asks for, what is the limiting size of the infected population? How many people would be affected at a T equals 1,000 or infinity, T equals infinity? Now, when you think about that, you're talking about, if you go back to the original question, it says, if I can find the original question here. Doesn't really say, but the most that it can be is this top number right here, the 5,700, because if I go to infinity for time, it's just going to get closer and closer to this number being 0. So this divided by 1 would just be 57,500 or 575,000. So that would be my, what they call limiting population would be this. All right, we don't have time for that last one, so I'm going to give you an answer for it. So 13.5% is the first answer. And I guess that's all. There's just one answer on number 14. All right, so this assignment is due with the other two by Sunday. Then, guys, I'm serious. We only have the 11.1, 11.3 next week, and then your finals after that. So have everybody had the chance to turn in some homework that you wanted me to reopen for you?
I need to send you that email, I forgot.
Okay, so if you haven't done that, then send that email to me. If there's any questions that you have, Grady, you're gonna come by and get a calculator, right? So you can try these with calculator. Grady? Did we lose Grady already? Okay, well, thank you guys very much. If you have any questions, please let me know, okay?
Thank
Okay.
you. Times.
Thank you.
Bye,
Bye.
guys. Have a good day.
You too.
Day is going fast.
Yeah.
Next 3 weeks is probably gonna go really fast. So you guys finished with most of your stuff?